In this session, we'll take a look at the distance formula, we'll take a look at the midpoint formula, and we'll also take a look at a circle. First off, we'll talk about the distance formula. And the distance formula is given as the distance d, which is the square root of x sub 1 minus x sub 2 quantity square, plus y sub 1 minus y sub 2 quantity square. Sometimes you may see this formula written in a different fashion. You may see it written as x sub 2 minus x sub 1 quantity square plus y sub 2 minus y sub 1 quantity square. Okay, but for our purposes, and just to remain kind of consistent in what we'll do, we'll use the form given. Next, we'll take a look at the midpoint. And what the midpoint will give you, it will give you the coordinates for the middle of a line segment. And that formula is given as x sub 1 plus x sub 2 quantity divided by 2, comma y sub 1 plus y sub 2 quantity divided by 2. Notice that the midpoint formula will actually give you an x and a y ordered pair. So let's take a look at an example. Here we're asked to find the distance and the midpoint between the following points: 5, negative 1 and 9, 2. We'll start by plotting the points. I'll first plot the point 5, negative 1. Remember, when plotting points, you should always start at the origin. The x coordinate tells us to move left or right, and the y coordinate tells us the up and down movement. So we're starting at the origin. Our x coordinate is positive 5, so I'm going to move 5 places to the right. My y coordinate is negative 1. I'm going to move down 1 place. So I have my coordinates 5, negative 1. And now I'm going to plot the points 9, 2. Here again, I'll start at the origin. My x coordinate is positive 9, so I'll move 9 places to the right. My y coordinate is positive 2, so I'm going to go up 2. And if I connect the 2 points, this is my line segment. Now, how can we find the distance between these 2 points? Well, we're going to use the distance formula. We're going to use the points 5, negative 1 and 9, 2. We're going to let 5, negative 1, let that represent our first point. So I'm going to just label that x sub 1, y sub 1. We have our second point, which is 9, 2. I'm going to label that x sub 2, y sub 2. And now I'm going to simply substitute into the distance formula. So recall that the distance formula is the square root of x sub 1 minus x sub 2 quantity square plus y sub 1 minus y sub 2 quantity square. And now I'm going to substitute. So x sub 1 is 5, and I have a minus because there's a minus in my formula. X sub 2 is 9. That quantity is square plus y sub 1, which is negative 1. Then there's a minus because I have a minus in my formula. And y sub 2 is 2. And that quantity is also squared. Remember, we're still inside our square root. Next thing we'll do is use the order operations and simplify the innermost parentheses. So if we simplify our first set of parentheses, 5 minus 9 is negative 4. Right, that quantity is still squared. Negative 1 minus 2 is negative 3. That quantity is still squared. Next we have negative 4 squared, which is 16, plus negative 3 squared, which is 9, which is equal to the square root of 25, which is equal to 5. Right? So the distance between these 2 points would be 5 units. Right? The distance between those 2 points would be 5 units. Now let's take a look at the midpoint. So we're going to take the same 2 points and we're going to find the midpoint. So again, x1, y1, x2, y2. So we have x sub 1, which is 5, plus x sub 2, which is 9, divided by 2, comma, y sub 1, which is negative 1, plus y sub 2, which is 2, divided by 2. We have 14 over 2, comma half, which gives us 7 comma 1 half. So if we were to plot that point, 7 comma 1 half, right? I'm at the origin. I will go over 7 places to the right. I will go up approximately 1 half, and we have our midpoint. Okay, next we'll take a look at first of all a circle. And we have here the center radius form of a circle. And the center radius form of a circle is given. It's x minus h quantity squared plus y minus k quantity squared is equal to r squared. Where the center is h comma k and the radius is r. Okay. So I'm actually going to sketch out a diagram on how this center radius form is derived. So just keep in mind that a circle is a set of points equidistant from a fixed point. And the distance is called the fixed point is called the center, and the distance is called the radius. Okay, so we have a circle. Its center has the coordinates h comma k. Right, so keep in mind this thing is within an x and y coordinate system. It intersects our circle. We're going to give this the coordinates x comma y. So keep in mind that the center is h comma k. The distance, so keep in mind we just talked about the distance, right? And we're actually going to find the distance between these 2 points. That distance is called the radius. So we're going to set this up as r is equal to, right, the square root. So keep in mind we're using that distance formula where the distance between these 2 points is our radius r, and we're going to label x comma y. We're going to label that as x sub 1 comma y sub 1. We're going to label h comma k as x sub 2 comma y sub 2, and we're going to use the distance formula. So the distance formula says is x sub 1 minus x sub 2, right? So we have x minus h quantity square plus, right, the distance formula tells us that it's plus y sub 1 minus y sub 2. So in this case, we have y sub 1 is y. We have y sub 2 is k. And if we square both sides, we square r, we get r squared. If we square the square root, the square and square root cancels. And out pops the center radius form. Right, so the center is h comma k, and the radius is equal to r. All right, so let's take a look at an example. Here we're asked to find the center radius form of a circle with the center given as 3, -2 and a radius of 3. First off, we're going to plot the circle on the graph. And the first thing I'm going to do here is I'm going to plot the center. So we're given the center as 3, 2. So once again, I'm at the origin. Since x is +3, I'm going to move 3 places to the right. Since y is -2, I'm going to go down 2. Next, we have that our radius is 3. So keep in mind that the radius is the distance from the center to the outermost rim of our circle. So in order to sketch this out, from the center, I'm going to go up 3. So I'm at my center, I'm going to go up 3, 1, 2, 3. I'm going to go to the right 3, 1, 2, 3. I'm going to sketch a little dot. I'm going to go down 3, 1, 2, 3. And to the left 3, 1, 2, 3. Right. And if I sketch my circle, all right, this is what the sketch of the graph looks like. Now, how do we actually write out the equation in center radius form? Well, we're actually going to use center radius form. So just recall that center radius form is x minus h quantity squared plus y minus k quantity squared is equal to r squared. Here we're going to substitute in the center as 3, -2. Alright, so here we have the center as h, k, and we have the radius equal to 3, which is r. Right, so we're going to substitute these things in. So we have x minus h, right, and h is 3, quantity squared, plus y minus, because there's a minus in our formula, k, which is a -2, so we must be careful to substitute in -2. That's equal to r, which is 3 squared. And now if we simplify, we have x minus 3 quantity square plus y plus 2 quantity square is equal to 9 as our equation. Okay, now we'll take a look at the last example, and here we're asked to find the center and radius of a circle that's in what's called the general form of a circle. So we have x squared plus y squared plus 2x plus 6y minus 17 is equal to 0. In order to transform general form into center radius form, we have to do what's called completing the square. There's a separate video posted beneath this video which shows you how to complete the square. So assuming that you know how to complete the square, and I would suggest you watch the video posted, the first thing I'm going to do is group variables. So I'm going to group my x variables. So I have x squared plus 2x. So I'm going to group those with a set of parentheses. I'm going to group my y variables. So we have y squared plus 6y. And I'm going to move 17 to the right hand side. So its sign changes, so we have it equal to 17. Next, we're going to complete the square with both the x and the y variables. So here we have x squared plus 2x. And I'll explain what I'm doing in just one second. Okay, so here is our basic setup for completing the square. So when we complete the square for our x terms, notice we have our squared term and our first degree term. Notice that the coefficient of the squared term must be 1, right? So we have the satisfied conditions in order to complete the square. The next thing we do is we take half of the coefficient of the middle term. So keep in mind the coefficient for the middle of the x variable is 2. So we're going to take half of 2 and we're going to square it. So 2 divided by 2 is 1. 1 squared is 1. So we have a 1. Now there's something special that happens when you complete the square. You actually create what's called a perfect square trinomial. Okay, and we'll talk about that in just one second. Now we're going to complete the square with the y variable. So once again, we have the squared term and the first degree term for our y variables, and the coefficient for our squared term is 1, so we have the right condition. In order to complete the square, we're going to take the coefficient, which is the number part of our middle term, which is 6. We're going to divide that by 2 and square it. So 6 divided by 2 is 3, and 3 squared is 9. So now you notice I added 2 blanks on the right hand side. Here's the reason for the 2 blanks. Whenever you're performing algebraic manipulations, there's something called the property of equality. And the property of equality states that whatever you do to one side, you must do the exact same thing to the other side. So if you were to add something to one side of your equation, you must add the exact same thing to the other side of your equation. So here is what I mean by that. If we look at our complete the square, so I'm actually here. If we look at this first term, x squared, notice that we started with x squared. We have 2x. Notice that we started with 2x. Notice once we completed the square, we added a 1, and notice that 1, the 1 is not on the left-hand side. We added it to the left-hand side, so we must also add the same quantity to the right-hand side. And if you look at the y variable, the same thing happens for 9. Right? We started with the y squared variable. We started with the 6y. Right? But when we completed the square, we added 9 to the left-hand side. So we must also add 9 to the right-hand side. So now if we look on the left-hand side at our very first term in this case, because we're using a set of parentheses, x squared plus 2x plus 1 can be factored as x plus 1 quantity square. So that means if you were to take x plus 1 and multiply x plus 1, you would get x squared plus 2x plus 1, right? That's what you call a perfect square trinomial. Plus, Y squared plus 6y plus 9 is also a perfect square trinomial. We can factor y squared plus 6y plus 9 down to y plus 3 quantity squared. And here's where the 1 and the 3 come from. If we look at the first y variable, when we completed the square, we took 2 divided by 2. Right? So I just wrote 2 over 2, but that's actually a 1. This 1 is what goes here. When we completed the square for our second y variable, notice we had 6 divided by 2 squared. Well, 6 divided by 2 is 3. So we have equals to 27. So we want to find the center and the radius. So the center for our problem is going to be -1 comma -3. So keep in mind that the h and k values will change. And also, if r squared is equal to 27, we take the square root of both sides. So the square root of 27 simplifies down to give us 3 square root of 3. So we have our center as 1, -1. We have our center as -1 comma -3. And our radius as 3 square root of 3. Thanks for watching.